I'm sorry.
All right, guys, let's take a look at these. Woo. Is this true?
No.
Oh, yeah, it's got to be absolute value. So they said for any real number A. If they would have said for any positive number A, then it would have been true. But you got to throw absolute values in there if I don't know what A is to cover my ass for if it's negative. Right? What about number 4 though?
It is true.
Totally true because it's odd root. And odd roots are laid back. They're like, I don't care if it's negative. I'm cool with that. Exactly how they sound. Little known fact. What about number 5 says, I forget now. Oh yeah, it said, how do I rewrite this? Is there more than one way to rewrite this?
Yes.
Hell yeah. It's exactly the 2 ways they said, right? That's true. They put the 2 on the inside of the root or they put the 2 on the outside of the root. Either way. Okay, how are we doing so far? Alright. 8 says, is the domain of this all non-negative numbers?
No.
No, hell no.
It has to be greater than
So, isn't 3 a non-negative number?
Yes.
Does 3 work?
No.
No. So you don't have to do any real work. But if you did do the domain, it would look like the inside greater than or equal to 0. So x would have to be greater than or equal to 5. So it's not all non-negative numbers, right? 4 doesn't work. 1.792443 doesn't work, for example. Right? How are we doing there? We all right? All right. Number 9.
7/3.
Beautiful. Square root of 49 is 7. Square root of 9 is 3. Kick ass. Number 11. When you throw a 16 in,
5.
yeah, you get 32 minus 7 is 25. Square root of 5. Square root of 25 is 5. I like it. That one should not have been too evil. All right, so don't forget, functional notation is just substitution, right? Just substitute it in. They should have asked this question first because it kind of threw some of you guys off. This is not the function, this is the function. So what's the domain of that function? We did one already just like that. How do I set it up?
2x minus.
So x has got to be greater than or equal to
7/2.
7 halves. Big ass. All right.
The sign on it flips when it's negative. It would have been negative.
Exactly. It only flips. If it would have been 7 minus 2x, when I divide by that negative 2, it would have flipped the sign. But it didn't divide by negative, so I don't. 13 freaked a little bit of us out because they put half of the problem on the next side up, right? So it wanted you to throw in all these numbers like 300. Yet the first thing you had to figure out is what variable does it go in for? And it goes in for x. And this is really just an exercise to make sure you can use your square root button on your calculator. Right? So you throw a 300 in there, negative 5 plus 6.7 times 300. One little evil thing about the square root button in your calculators, on the TI, on the scientific, you have got to put a parenthesis, and then you close it. If you close it too early, you're outside of the radical. You're outside of the square root symbol. Some of the newer TIs, your square root symbol grows. Does anybody have one of those? You don't want to admit it. Okay. A few of you guys have TIs, maybe some older ones. I have an old one. My square root symbol opens up like that. And I don't want to close it. Anything after this is going to be outside the radical. The newer ones, the square root symbol actually grows and just covers everything. That's kind of nice. Ooh, nice for them. People with new stuff. Anyways, this is like the first one. I can't remember now. What was it? 34.57. What?
Pounds.
Yeah.
Of milk.
30 pounds.
Pounds of milk. Say again, sorry? There's half of a question. What's up? So let's do this one up on in the calculator real quick. was that gonna last?
What did you get?
Hmm?
4 point? No, negative 4. No.
Where are you at?
Still 13?
Which one?
Really?
Yeah.
No, that's what he just said. But then not close it. Or close it at the end.
I didn't do it that way at all. But I still came out with the same answer.
It's the same, yeah.
Alright.
I did all the math inside first and got one number to get a square root of, so just hit square root of that number.
So I'm gonna do it on the TI calculator, but it would look the same in your scientific calculator if you have one of those.
Oh, but didn't you?
There it is. Alright,
So
cool.
you didn't
So if I want to do this, it would be negative 5
just times minus.
plus square
Right,
root
with that. 6.7 times
6.7. See how it opens a parenthesis for me?
3. Yeah.
6.7 times 300 minus 444, and then I can close it. Now that's the end of my square root.
Yeah. Oh, wait.
So let's see if we get 34.57 business. Cool. And then the rest of them are the same way. Just to show you something kind of neat, if you do have a TI or even a scientific, you should be able to go back up and edit what you've done before. So if you hit second, enter, I can then just go up here and change this 300 to 200. So I don't have to type all this crap back in. Yay! Easier.
So wouldn't it be easier to just calculate 6.7 times 300 minus 444 first?
And then get the square root of one
And
number.
then, yeah, you get 1,566.
That's how I did it.
That's fine. This is
But I
one
get,
step
if I
and
do
I'm
it
done.
that way, I get another...
One step and I'm done. And I don't make a mistake of throwing something in the wrong place. But if it makes more sense to do it in parts, you can do it that way. No problem. Cool.
Because I got the same answer, so.
Yeah, that's
I
awesome.
did.
Yeah, so you can do it in parts. You can do the inside of the square roots first and then take the square root of it. So
I didn't even know if that would work on this kind of calculator.
Oh, that,
It's a
yeah.
little dollar store calculator here.
Ah,
Right? Like this.
cool. All right. So
But
anything
look
about
what-
that
look what
there?
happens. Oh,
All right.
no, well, that's new. That's what I got. And that's not the answer. Completely different.
Where's the mistake then?
What about number 14?
Laplace is important.
Yeah, you could say this. But is 5 ever negative?
No, it doesn't. Not just
No. So you could more directly you could say that. Either way, I'll take it.
something else too.
Why do you need absolute value?
Because of the T.
It could represent any real number. This is an even root, so I have to have the answer come out positive.
Okay, thank you.
Cool.
So because the two,
The only part of this that could be negative is the t. So these are the same thing. 5 is 5. I don't care how I look at it. So I could put it inside absolute value. I could put it outside absolute value. It doesn't care. Because 5 is 5. T is the one that's like, holy crap. It could be negative, positive. All right. Well, and the same thing with 15, really.
Right? That's,
The square root and the square. So it is c plus 8, but just to cover our ass, we put in absolute values, just in case c plus 8 is negative. All right.
and if you don't put it, it's wrong.
Say again?
Maybe you don't put that.
It's very wrong. Yes. Cool. Not cool.
And again, that's because the variable. So could it have just been the variable in the absolute value?
No, definitely not. Because, how do I say this? If c is negative 10, then this number is negative 2. Right? And then the absolute value would be 2. But if I said absolute value is c plus 8, absolute value negative 10 is 10, plus 8 is 18. So that's not the same thing. So it's the difference between how addition works with things and how multiplication works with things. Multiplication, they are actually more like parts. You can factor them apart and stuff. Here, these are kind of tied together more than you think. C plus 8 is a number. I have to know what the whole number is before I can do the absolute value. I can't just do an absolute value of a piece of it. How we doing? All right. So I read you even less today. It's like negative perception of how you're doing today. It's weird. Yes?
Question back to 13. On the book, it rounds the answers.
I know it
Do you
does.
want us to do that?
It didn't say to.
Okay.
So like I said, if it doesn't say, go to a couple places.
Okay.
Yeah. So they just arbitrarily chose to go to one place. Good for them.
So there's this square in 14 and 15. They all do not have absolute values.
Because it's a square root, it's an even root. So the answer can't come out negative. So you just got to throw out your values around it. So on 14, if you write this, you're fine. It's not wrong. You just don't have to have the 5 in there because it's already positive.
Alright, and then what if it was 4? What is it? 4?
Fourth root?
Yeah, 4.
So it's still an even root. You would still have to have absolute values.
So all even.
All the even roots, they're very uptight. They can't handle negatives inside. They can't have negative answers. Odd roots, completely laid back. Because they always have that last dude that helps determine the sign. Even roots, holy shit, if it's negative, it's positive. Everything comes out positive. They can't handle it. Odd roots, very laid back. All right. Okay. 16, I wrote it like this because the first thing you want to do in number 16 is factor it. I think that's right, if I remember correctly. There it is, yeah. So then how do I do this? Good. Those die and the absolute value of 2x plus 1. Kick ass.
Don't
All right.
we get two little things?
There are 2 little things inside. Yes, that's why it was squared. I'm sorry. So yeah, it would be 2x plus 1. 2x plus 1.
I can see. I can.
Gotcha. 17, we actually already did that one. Oh, sorry.
For 16, you have to factor it out.
Say it one more time.
For 16, you have to factor it out first, right?
Have to.
Okay, and then what do you get to plus 1?
Factored it out.
Okay.
Yeah.
Okay, okay.
4 times 1 is 4. Factors of 4 that make 4 are 2 and 2. Right? You could do the surefire method if you want. Yeah. Yes.
On number 8, you did that. You said it greater than or equal to 0 to find the domain.
Good.
So in 16, why wouldn't you do that?
Because that's not the question.
It's not the domain. So what is the question? Just
The question is simplify.
Simplify.
So watch. If I said simplify this, what would you do? Factor out the bottom. Cancel what you can. That's the end. That's simplified, right?
Yeah.
There are 2 numbers that x can't be, but they didn't ask me for the domain. I got to understand that that's always true. X can't be 1 or negative 1, right? But the question was simplify. So I didn't really worry too much about finding the domain. I just got to simplify. So this one, simplify it. I could find the domain, but there's no real reason. Yeah. All right. Catching on. So what about this guy? We did this one earlier, right?
2.
Why can they handle negative?
Because it's odd.
Because it's odd root, right? So negative 32, you can break it up into a bunch of negative 2s. Yeah. No, you're not going to fit 32. That came up a few times today. 32
Yeah.
is 5 2s. What about number 18?
5A, B, 4, over 2.
Yeah, good. 5AB. 4 is the power. 3 is the root. Done. That's all there is to it, right? Roots go on the bottom. Powers go on the top.
Does it have to be in parentheses?
Totally. Because what's being cube rooted?
Oh,
So
the
if you
whole
write
thing.
this,
I see. Right.
what's the only thing being cube rooted? The B. The 5 and the A are just 5A. They're hanging out. No, that can't be
Okay.
right. The whole thing is being cube rooted and fourth powered, right? Good.
Okay, good.
I like it. Guys look way excited about this.
This is as excited as
And
I
you
look
talking
at
about
that.
it makes me even more excited. So what about number, where am I at?
18, 20.
20.
X is third power and Y is third power.
Now what do the instructions on 20 say?
Oh,
Something different.
Irrational exponents to simplify.
But more than that.
Assume x, y.
So do I need absolute values?
No.
Good. If you put them, I'm not going to mark you wrong. But in some of the homework, they don't want you to worry about absolute values. They just want you to worry about that one idea. So they'll say, assume that everything is positive or something, or like this. You guys kind of with me? So then you don't have to worry about absolute values. If you put them, I wouldn't mark you wrong. 22 freaked a few people out. But real quick, here's the thing about math. And if you get what I'm about to say, you'll be able to do math really, really, really well. Math processes don't care what's in the problem. So if the process is powers, it doesn't care what's in the problem. So if I had x squared to the 7th power, what's that? X to the 14th, right? Because we know that you multiply. There's 7 groups of 2x's. That's 14, of course. But math doesn't care that these have to be nice numbers. They don't have to be. They can even be freaking letters. X to the m to the n.
X to the mn.
X to the mn. And what can m and n be? They could be fractions, right? But what do you do? What's the process? You just take these and you multiply. What kicks ass about this one? So you get x to the
Negative 2/5.
negative 2/5. And did it say anything about do not use negative powers in your answer? So I love it when people just erase it. So not to, man. But yeah, you have to rewrite it. So this will be
1 over x to the 2/5.
kick ass. You don't have to take it all the way down to radical form. If you do, you're not wrong, but you don't have to. Cool. So you're going to see stuff like, what you got, Jeff? I don't know. X to the 3/4 times x to the negative 4/7. What would you do there?
Add them or subtract?
Careful. What's the property? You add. Yeah. In fact, like
We'll add
11 years ago, I was tutoring some cheerleader, and she said she had this whole thing. It was really, but she said, okay, when you multiply, you add. All right, so it's too easy. So when you multiply like bases, you add the powers. And she had other stuff. That's all I can remember. It's freaking 12 years ago. So yeah, when I multiply stuff like bases, I add the powers. So you'd have to get
LCD.
See, so math doesn't care. It says no matter what the hell these are, you add them, and we go, oh shit, they're fractions. I need LCD. But math doesn't care. Math just says you got to add them. If they're like this, you got to multiply them. If they're like that, he doesn't care if it's fractions or if it's the letters. Who cares? So I had that one bonus problem that had a bunch of like 2n plus 1. Remember this?
Yes.
And it was even over something. Because the properties don't care. What would you do here?
add them.
Add. So what's 2m minus m? And what's 1 minus 4? And they had stuff on the bottom, but then you would subtract the powers, right? See, so the properties don't care. Whatever's there, you add them. If they're divided, you subtract them. Okay, baby.
If there were two different variables at the base of it,
Then I wouldn't do anything.
it would do, oh yeah.
This is all predicated on these being the same base, right? If that was a y, I'd have nothing to do. It'd be simplified already, right? Cool. Okay. So based off of what we just said, the biggest mistake I see here, and I can't blame you too much, is people cancel the 7s. There is no 7 up here. There's no 7. It's like, Jeff, dude. Yeah, there is. I'll go get some help for you. There's no 7. There's a third of a 7 there. It's to a negative power. There's a half of a 7 there. You can't cancel these 7s because there are no 7s. What do you do when you have like bases and you're dividing?
You flip them, right?
Yeah, good. So negative power should flip. So you get 7 to the 1/2 over 7 to the... Now what do you do with these powers? Subtract. Good. Like bases, you subtract the powers when you're dividing. So like I just said, you have to get what?
LCD.
LCD. So it'll be 3/6 minus 2/6. You should get 7 to the 1/6. Done. I desperately want you guys to understand there's nothing new up there. Not a damn new thing. We know the properties of exponents, or you should. So when you multiply like bases, you add. When you raise something with a power to a power, you multiply the power, stuff like that. I don't care what those powers are.
I have a question.
Yes?
For that one, negative 4 over 7, do you move that to the bottom if it's a y?
Where am I at? Oh, here.
Yeah, if that's a y.
Yeah, the only thing, if this was a y, the only thing you could really do is flip it and then stop.
Oh,
Yeah,
okay.
yeah, because we don't like negative powers. Yeah, good. I like it. What about 25 there? 4 through to 16?
2
2?
x to the 5th,
Good. 4 goes into 25 times, 4 goes into 8.
y squared.
Twice. Cool. I think this one said, it's in the same section, right? Assume that all variables are non-negative, so you don't have to worry about absolute value. All right. Because what does it take 4 of to multiply to be 16? Yeah. It's unfortunate that the symbol they picked, and this is interesting too. The symbol, we didn't look up in the sky and see a constellation that was shaped like this, and then some deity came down and said, "Thou shalt use this symbol to meet." No. We made the symbol up. The symbol could have been a box with a 4 on the edge, and that would mean the 4th root. Right? And the guy that came up with this, he said, "Oh, you're freaky. Get the hell out of here. We prefer this one." But even this one kind of sucks because it looks like division, doesn't it? That's part of the reason they liked it, because breaking something up multiplicatively is sort of like dividing it up into parts. So they kind of liked it, but it also confuses students, because students are like, is it the 4th root, or is that 4 divided into something? I know, oh gosh. But normally when you talk about this, you're past long division, so it's pretty obvious which one it is. All right. All right, all right. Good God, it's a lot of math. All right. So everybody got what you want from there?
I'm sorry, go over number 23 again. I can't remember how you got the set.
All right, let me write it up here a little bit bigger. So you're cool with the flipping,
Yeah.
right? Because the negative power makes it flip. So then you have 7 to the 1/2 minus 1/3, because it's subtract powers. And then what's the LCD? Because now it's just a fraction subtraction problem. Fraction subtraction. What's your action? Good job.
So you took the 7.5 over 7 1/3, right?
Yes. Because this 1/2 of a 7 is negative power, so it wants to go up. And this is negative power, so it wants to come down. So they just switch places. First thing I do, and trust me, there are other ways to do this, but it's just so much easier. You're not going to make a negative mistake if you move all your negative powers first. So you lose all those negatives.
But isn't that a division problem now? 7.5 over 7 1/3?
Beautiful. So real quick, before you say anything else, what's the answer to this?
Is that x to the 7?
Yes.
So x to the 2.
Yeah. You took that minus that. That's what you always do. When you divide like bases, our bases are 7. When you divide like bases, you subtract the powers. We know that's what we do. We just think that looks different, so it must be different. No, math doesn't care.
I was just thinking about crossing out the 7.
Oh yeah, I understand. But I mean, would you ever consider canceling the x's here? Maybe, but normally we're past that. We would never think about that. That would be so weird. But the minute I put a 7 or a 3 in there, if I had 3 to the 7th over 3 to the 5th, I always get somebody telling me it's 1 squared. I mean, no. I had 7 3s. If you divide 5 of them away, I should still have some 3s, right? Don't take all my 3s. So I have 7 3s, 5 3s. So it should be 2 3s at the end, right? So the bases don't change. Just the amount of that base changes. Yes, ma'am.
For 23, okay, so I get how you get the 6 because you want to find the lowest.
LCD?
Yeah. Okay, so you would multiply 6 into 1/2?
No. Just make it something 6th, right?
Yeah,
So-
but like, wouldn't you have to do it to the top and bottom?
Of course.
So it would be like,
Oh, I see what you're saying. But don't multiply by 6, just multiply by what makes it 6, right? Multiply by 3. So you get 3, 6 minus
yeah. So,
2, 6 is 7 to the
oh,
1 6. Yeah. So the minute you write it in this form, your attention shifts and you realize, oh, it's just a fraction subtraction problem. Don't make me sing again. You don't want me to. All right. Y'all look beaten down and oppressed.
No one
Good.
can.
I'm doing my job. All right. We have a separate class we take home. Okay. So, I just want to do a little bit more out of 12 and then we'll head out for today. By the way, we're going to have a quiz on, what day is it today? We're going to have a quiz on Thursday over whatever section we get into today.
And the next Monday, you have another test.
No. Next Wednesday.
I know, but when's our next date?
Next Wednesday. Yes. It's on the homework sheet. I've got the test dates on there. It's only 2 tests.
Friday.
And then next Friday is the final exam.
Already.
Dude, 3 weeks. Bam.
So that's 2 days after the second test is the final.
I know, it's crazy. So basically, that Wednesday we'll take a test. I'll have it graded by the next day. I've proven that to you guys.
Correct.
On Thursday will basically be review day. We might have to do a little bit of new stuff, but we'll see. Okay. Again, you guys took the 3 credit course. The class started getting rough.
It doesn't give me too much time to forget stuff, though,
This
for
is
the
true.
final. Like,
There's always a bit of a
it's
train
not that
off.
long ago, so I should be able to remember some of it.
We just got this here.
So when's the next test? Again?
Wednesday.
I love it, Chris.
Thursday?
Yes.
Number 19. Thursday.
From the section we're just doing? Oh. All right, guys. Remind me, how would you do this? This is the question. This is number 19 from the section we were just doing. How would you do this, though? Because it's really the same idea.
Multiply the exponents.
True. So would it be 2?
2 power 3.
Good. Don't forget. So what are exponents based on?
6.
What are exponents based on? Multiplication. So this is all multiplication, right? So that's why the exponent can just go to town. It's going to play well with multiplication. You never could do that if it was 2 plus. What would you have to do here? You have to write this 3 times and FOIL it out many times. Oh, shit. Just that 1 plus sign throws the whole thing to shit.
2 cubed, a to the 5th.
Good. 2 cubed. Careful. A to the 6. You multiply 3 groups of 2.
3.
Is 6. If it was a squared times a cubed, that's a to the 5th. But a squared cubed, what's something cubed mean? That thing 3 times. So what's a squared times a squared times a squared? A6. Why do that? It's the definition of multiplication, isn't it? 3 groups of 2 apples is 6 apples, right? Cool. All right, so all of that, so of course this would be b cubed, so they get 8. So all that just helps me with this. What do I do with the 3/4? Distribute. So I get 16 to the 3/4. What happens here?
Nothing, just multiply.
Multiply. Do you guys see that? You just distribute the power, right? Power distribution. Why am I allowed to do that? Because it's all multiplication on the inside. If that was a minus sign in the middle, that would be really weird. Couldn't do it. How do I do 16 to the 3/4?
4 through
4 through to 16
10.
to the 3rd. And what happens with the A's?
Okay,
Cancel a 2 out, so you get a to the,
9,
what's this, 4 through to 16?
2,
2 cubed?
8.
8. There it is. So the whole idea really is the same as this problem. This problem looked easier because that's not a fraction. The math process doesn't care. It says whatever the hell that thing is, you distribute it to both. And then I can simplify each piece. It's when you think that you're supposed to be able to go further. So some people try to skip the middle step of actually putting the power on each so you can really see what to do in each case. That's when you start to get all these neat, made-up, creative answers. Yeah?
So you just take 3/4 and just slap it on the 16?
Exactly, because what did we do with the 3? We slapped it on the 2, we slapped it on these guys. So math, again, doesn't care. That being a 3 is not special. Whatever the hell is up here over a multiplication gets put on everything.
So I lost you there, so it's 4 to the 16, or 4,
Fourth root
to,
of 16.
to the third,
Good.
and then A,
To the 9/2.
and where did you put that? I mean, it's just hanging out there someplace, and then
This?
Uh-huh,
Yeah, it's there.
it's waiting.
Yeah.
Okay.
So it's this business times this business. So I just at the end collect them all together.
Okay.
You love it, I can tell. All right. What about this here? We've sort of done this already. Let's see what you guys think. What's the square root? What do you think the square root of 5 times the square root of 7? What do you hope that is?
Square root of 5 times 7?
Square root of
35.
35. And your hope is true. Thank God. Really, math actually did something that I wanted it to do? Yes. And the reason this works is sort of the reverse of this. If I have a multiplication in here, I can bring the power in, right? So I could bring it back out if I wanted to. So watch this, watch.
4.
This is 5 to the what power?
4 1. Sorry.
1/2.
1/2. And this is 7 to the...
1.
And I know I hear you guys are like, why are you making this so hard? This is square root of 35. You would be done. I'm explaining why that's true now, right? So these both have a 1/2 power, so I could take it back out. So it would be 5 times 7. You guys see that step? It's the reverse of this step. If I could put it in, I could take it out. And then what's 5 times 7?
35.
And what's 35 to the 1/2?
Square root of that.
So I always love it. I always get people later after class and say, why did you want me to show all that? No, don't show this. That's the reason why this is that easy. So what does it require to be true then for each piece? They have to have
The same root.
the same root. That was your point, right, Keith?
Yes.
Good point. I like it. So if I had the square root of 5 times the cube root of 7, and I said simplify, you could circle that and say, next. Bring it, math boy. Right? Yeah.
If you did 5 to the 1/2 times 7 to the 2/3, and then
Well, it'd be 1/3, but then the bases aren't the
Yeah,
same. Do you
1/3,
see what I'm
yeah.
saying? If
close to the, okay.
now watch, you're,
Oh,
you're
right.
reading my mind. You're freaking me out. Because what if I had this instead? Poor little camera.
Oh.
It's my bad. Focus. Daniel-san. Okay. Maybe. So what if I had this? Square root of x times the cube root of x. Now believe it or not, there is something I can do. It doesn't look like it right now because radical form is actually not the better form. Do you remember I was saying earlier we didn't even need it? Because what is square root of x?
X to the 1/2.
What's the cube root of x?
X to the 1/3.
X to the 1/3.
What can I do now?
Add the exponents.
And I really want you guys to get this. We basically already did this problem almost, except there was minus over here. But of course it would be 6th root, right? 6 on the bottom.
Yeah.
So it would be 3, 6 plus 2, 6. Remind me, what's on the bottom? Why was this 1/2? Because it was a
Root.
Square root.
square root. When we do LCD, do you see how we're forcing the roots to be the same? Now they're both the 6th root. So they have to be the same root before you can do them. If they're not, LCD makes them the same root, and that's why I'm allowed to keep going. Now I couldn't do that here because the bases
Or 1/2.
would not be the same. Right? This would be 5 to the 1/2 times 7 to the 1/3. I can't do shit there. If they were both 5, I could do what we did over there. Right? But the base would have to be the same for both. Do you guys see that?
So would that stay that way, or would you have to convert it to with this?
Yeah, you could put it, it depends on what they say. Normally, if it doesn't say anything, you put it back in the form it started in. Right? So how would this go into root form?
6.
Good. So this is called exponential form. Again, math people are very creative. It's an exponent. Let's call it exponential. And then this is called, now this is a little more interesting. This is called radical, tubular. Right?
Is it the same thing if you did the parentheses and the 5 exponent on the outside of the parentheses?
Oh, yeah. You could write this. I mean, technically this is correct. If this is a variable, we choose to do this way because it's a little less writing. If it's a number and I can do something with it, then I put the power on the outside so it's easier to do the inside, right? Like it was with the 16 to the 3/4 power or something. Yeah.
From number 19 and the problem we're working on now, why on that one we multiplied the exponent fractions if you were adding them?
Because this was stuff with exponents raised to a power. This is stuff with exponents who are multiplying each other. It's the difference between, now watch. So here I have x to the 1/2 times x to the 1/3. I have to add these, right? What if I had x to the 1/2 to the 1/3? These I would multiply. Good. When you multiply like bases, you add the powers. When you raise something with a power to power, you multiply it. In my head, I always think it's always one level. Screw it. It's always one level down. Multiplication becomes addition of powers. Raising becomes multiplication of powers. It's always like one level down.
And what's above that one?
Dude, you don't want to go there.
Come on, Math 800.
You got to talk about tensors, multidimensional matrices.
Go for it.
I have a quick question. How did you
Yes.
get the 6? Are they,
So this one's the third one?
yeah.
Yeah, so if I have to add these, I have to get an LCD.
Okay.
Yeah. Cool. All right. Let's see, blah, blah, blah. So we sort of have done this already, but we've done it with, remind me how to do this kind of thing here.
One over.
That was so long ago.
No.
5 goes into
It's in
9 once with
4 levels.
Four left.
an alternate way to do this. You ready? An alternate way to do this. And sometimes people like this alternate way better, because you can kind of see better where things are coming from, is to rewrite a 9 as something the 5 likes times the rest. Now, if I'm allowed to combine things that have the same roots, I can pull them back apart. So watch now. This is the same thing. See how I pulled it back apart? What's the 5th root of A5? A. What's the 5th root of A4? I don't know. So you get the same answer either way. So I like the shortcut, of course, because it's less work. But I understand some people like to be able to see exactly where everything's coming from, but this is really why the shortcut works. All right. So the next level of this, so always another level, is what if I had the square root of 50? Can somebody tell me, give me a guess as to what the square root of 50 is? Give me a guess.
25? What's it like?
No.
25 would be 25 to 25 is huge, right?
6.2.
50 is just a little over 49. Why is 49? Why am I even bringing 49 up?
7?
The square root of 49 is,
7.
so a guess for this would be like 7.02. You know, make something up. You kind of with me? So it's a little bit bigger than 7, because 50 is a little bit bigger than 49.
You can't do it. You said like 25.
No, we can't. We're going there. Oh, is that what you meant? Break it up. I'm with you. So an estimate for what this really is like 7 point something or other. But it's sort of like if I see 9/7, I want to be able to write that in a different form. I don't want to have a decimal that would never end. I just want to be able to write it. And of course, the different form here would be 1 and 2/7. So now watch. I really want you to let me overanalyze this to death. If I rewrite 9 as 7 plus 2. And the reason I do that is because I can do the part that I can. 7 divided by 7 is 1. And the 2 gets left. Because I can't do 2 over 7, right? So now watch. So this is what you're saying. Sorry, you're right. I thought you were trying to say 25 is the answer, but I can break 50 up into a part that I can do the square root of times whatever other mess there is. And of course that would be 25 times 2, right?
Which is 5 and...
I like it. So square root of 50 is square root of 25 times 2.
Which is
Break it up. Square root of 25 is?
5.
Square root of 2 is? I don't know. Third base.
Well,
Yes.
Where did that 8 come from? If you canceled it out.
Where are we at? Sorry?
Because you were moving fast, sorry. Oh, the one where your hand is at, right there, yeah. The 8 to the 5th.
Oh, no. It's okay. It's a fifth root. So these cancel. That leaves me with an A out here.
Oh, so you don't.
And then the fifth root of 4 A's, I don't know. So that's a fifth root. Yeah. Sure. Okay. Okay. So, this is kind of related to simplifying fractions. I always call this reducing a radical. Kind of breaking it down, right? So, you're no longer allowed, if you see something like the square root of, what you got, Jeff? Square root of 18. You can't just say you can't do it. You got to do it. You do it.
we don't want to break it up.
2
And
and
what
9.
if, for the variables,
It'd be 2 and...
Yeah, square root of 18 is square root of 9 times square root of 2.
which is 3 and 2. I mean, 3 and 3.
Now, I can break 18 as 3 times 6, right? Would that be smart?
No.
No, because neither one of those are doable. You always want to break it up into something you can do times the rest, right? Yes, ma'am.
Can you do the same thing? Can you break up the variables? If there's no...
That's exactly what we did here.
Oh,
Broke it up into something I could do, and I did it. Something I can't do,
Okay,
so I didn't do it. And that's why I wanted to remind you guys this method works, because that's how we deal with numbers. All right, maybe. So let me give you guys several to try. Start over here. My teacher would always say that exercise left for the student. What's that? If it works for square roots, it works for any root, this idea. But if you got a cube root, you don't want to use 4 times 6. You got to be careful about what numbers you want to try to break it up into, right? So we'll do these 3 and then we'll head out.
Okay.
Thankfully, I don't write my own tests, so it will be very easy to tell if it's a cube root or if there's a 3 in front, right? Two very different situations. I do make my own tests, I just do it on the computer. So I sure can read it. Number 3 is nowhere near as hard as you might think when you first look at it, because we already know a 5th root something, yeah. let me catch up to you guys. How do you break up the 98?
249.
Good. Square root of 49 is? Square root of 2 is? I don't know. Alright. Now on the 24 is a cube root. This is why I was saying earlier to make a list of cubes, a list of fourth powers even, right? So if you know what numbers are cubes, you got 1, then you got 8, right? Then you got 27, then you got 81. 8 goes into 24, kick ass.
Yeah.
So I can rewrite this as the cube root of 8 times the cube root of 3. Cube root of 8 is
2.
2. Cube root of 3, I don't know. It's kind of funny. Break it up into a part you can do and a part you can't. Do the part you can. Don't do the part you can't. It's kind of fun. And then this guy, fifth roots, the only real number we know is 32, and that's a part. This is 32 times 10, right? So the fifth root of 32 is 2. The fifth root of 10, I don't know. So the fifth root of 32 is 2. And that's why there's a 2 out there, right? 5 goes into 11 with 1. Done. Done with that problem and done with the class today. Yay! It's my favorite time of your class, Jeff. What?
What section in 12 in chapter 12 did you go up to?
12.3. We just made it all the way through 12.3.
20 by
Quiz on Thursday. We'll cover 12.1, 12.2, 12.3.
yeah.
So come with questions tomorrow.
That doesn't work too.
Those 3 sections are already up on my math lab. Say again? 12.1, 12.2, 12.3. Yep. No.
How many?
You get a point for every 4 you missed. You got a 76. You missed 24 points. All right, so it's basically the same thing. You missed about 24 points divided by 4 is 6. You get 6 points back.
Okay, so do I do all of them? Right, all of them? Or just
You only get that if you do all of them and get them all right. So if you only do a part, your points you get back fall down really quickly.
Okay, so I do the whole column.
If you do all the questions, get them all right, you get 6 points back.
I have a board problem.
What's up? Okay.
So,
You put it on that. Oh, you put it on there. Okay, cool. All right, thank you.
I have a question about the My Math Lab. I'm
Yeah.
using the 14-day free trial thing, and it expires. They want me to take a picture of it, show that I did the homework or something, because I don't have money to go right now. I mean,
When does it expire?
I think in the couple days.
All right.
So how do you want me to go about that? Then start doing the homework with the book? Do that.
Yeah, but you don't have the book. You're gonna start doing it from the library or something? All right. Double check on your expiration date. Shoot me an email with that date. You go ahead and take a picture of it, but if you tell me when it's going to expire, I'm going to try to capture it myself too. Yeah. Sure.
when does it expire? My math lab, does it expire?
No. He's got temporary access. So.
Oh, I did a trial period too.
But it should. I think it's based off of when you sign up.
Yeah.
But it should tell you when you log in how much longer you got.
Yeah.
I just don't want to pay for the rest of it either for...
Yeah, but you want to tell them because once it expires, it deletes all of your information.
Uh-oh.
Oh, no way.
Oh, hell yeah. So, I mean, that's the idea. So it's a good idea he had just to take a picture and show me.
So, just to be clear, I started doing it on this and then I switched to my math lab. So I'm prepared for these.
Yeah, so anything that's on my math lab, you don't even have to do the corrections. It'll just be, I can just look at my math lab.
Okay.
Yeah.
And I plan to do the same thing for the next section, so it's more practice. So I'll give you this, and then I'll use these corrections as to study.
Oh, good. Okay. Sure. Yeah.
You should take a picture of the work we've done so far.
Yeah, there should be you should be able to look at your overall status. Yeah. So I can see it too. So again, if you email me, I can try to capture it before you're
before it
Like,
expires.
you know how
Yeah.
I do it?
I should be able to see your expiration date too, but
You know?
I always gotta remember to do that.
I know, I need to do that.
Hold on, Mr. Shannon. My head is gonna hurt if I just look at the lines.
Oh, yeah.
So much lines. I don't know how you do
They
it.
should get a graphic notebook.
Huh? Yeah, you do all your homework on the graphic notebook?
Yeah, well, now I started.
You know,
on
the
it.
first part of this class was kind of review from the other math class. Now I'm cutting into new territory.
Oh,
I haven't been in school, you know, you gotta figure, I'm 50, I haven't been in school for a long time.
I got you. It's, yeah, some of it comes back and some of it stays hidden.
Well, I was a rebel